Hey everyone, this video is all about weather, and specifically windy cities. I always heard that Chicago is the windy city, but is it truly so? Or does another city deserve that title? Let's do some computational exploration to find out. In this video, we will be using the weather data function to get weather data. It has all types of weather data from temperature to pressure to, you guessed it, wind speed. We'll play around with it to understand its syntax. We can insert our desired city, say Chicago, and get the current temperature by calling quote temperature unquote. You may notice that this is in Celsius, but we can easily convert it to Fahrenheit by indicating that we want the non-metric value. I can also obtain other properties such as pressure by calling it directly using very similar syntax. Now, what if I want to obtain historical data? It is rather simple. I can just slap a date object after the city and property I would like. In my TS variable, I indicated that I want data for July 4th, 2020. I get this time series back, which is essentially a special form of data in which the x values are date objects. I can plot this time series using dateless plot, and as we can see, there's a missing area. I can try to find where the missing data is by getting the date path of my time series variable and applying the cases function. In here, I'm looking for the pattern in which the first element can be anything, but the second has to have a missing head. I end up with this lone missing value right here. Luckily, there's an easy way to treat this with time series. I can simply indicate that I want my missing data method to be automatic, and the Wolfram language performs its automatic algorithm to bridge the data, so to speak. It looks like pressure data on this day plummeted in the afternoon. Before moving on, we can ensure that there is no more missing data by once again applying the cases function, only this time we have the missing data method present. Okay, what if, instead of a specific day, I would like a range of dates instead? I can simply indicate in a list my date range and I will get that range of values back. In here, I am looking at pressure in Chicago from the beginning to the end of 2019. We can see that this results in a time series with over 10,000 points. I can visualize this data using dateless plot, which returns a very rough looking plot with many missing values. Note that although we have missing values, a pattern is present, meaning we have enough points to treat the missing values by missing data method. We can confirm by using the cases function and looking for missing values in the date path of our time series, and we see about 1800 such values. As we talked about before, since the missing points are much less than the available data points, let's treat them using missing data method. We still have a very rough looking plot even after applying missing data method. Perhaps we can take the moving average to smooth out the data. In here, we'll apply the moving average function onto our time series and indicate that we want it for 1 week. And we'll also plot the original plot in the background with a low opacity. Note that in applying a moving average, we are averaging a moving and overlapping window of 1 week. Another solution is using time series aggregate, which instead of being a moving average in the sense that the average moves along the curve, it takes the average of each 1 week period. Note that we are now averaging a moving non-overlapping window of 1 week. In other words, if we'd like to know the average weekly values, we should use time series aggregate with a window of 1 week to get the following plot. Now on to answering our question. First, I wanted to compute the wind speed time series for some big cities. In here, I'll look at Chicago, New York City, Boston, and San Francisco. I can do that by setting up a pure function using weather data, which is indicated by the green hashtag and the ampersand, and mapping it onto a list of the cities I want data for. This will essentially replace my green hashtag successively and give me a list of time series for these 4 cities. I can get the mean by doing the same thing with the pure functions and mapping them onto the previous output, indicated by the percent symbol. This is in order, so we see that Chicago has the lowest mean wind speed in our data and San Francisco has the highest. Also note that the data is in kilometers per hour. But let's not get too excited just yet. We'll explore the data in more depth before making a conclusion. I wanted to plot my data to visualize it. Using the dateless plot function gives me a very rough looking plot which I can't really interpret. So, you know the drill. Let's use a moving average. Doing so clearly shows San Francisco as being on top, with Chicago having some windy periods, but certainly not like the other cities. I wanted to also look at the spread of values. I can do that through a violin plot, which is given by the distribution chart function. Applying that on my data shows me that Chicago has its average below the other cities in consideration, and that San Francisco has some very windy days, as indicated by its spread. Now that we have a basic handle of the data, let's explore the largest 20 cities in the United States and figure out which city is truly the windy city. First, I will get the entity list of the largest 20 cities in the US in terms of city population using entity class and entity list. Just for fun, I can visualize these cities by mapping a geomarker onto my data and plotting them using geographics. I'm using a tooltip here and indicating that I want the city's name as the label such that I can hover over geomarkers and see which city I am looking at. Now let's use association map to map my weather data pure function onto my list of big cities. The association map will make sure to associate my city entities with their corresponding time series for wind speeds. I can now visualize the distribution of wind speeds using a box whisker chart. Through eyeballing the visualization, San Francisco and New York easily beat Chicago. We must be careful, however, as box whisker charts don't show intensity or density of values, only information about their spread. What function shows us density then? A smooth histogram. Applying that function onto our data results in errors, however. What's wrong? There might be some missing data present. Let's first look for cities with no missing data by using select and free Q and getting the keys to only get the cities. We can now take a complement between the keys of all our data and our output above, and it looks like that city is Dallas. It's no biggie though. We can just set up a new clean variable where we map this pure function onto our data. In our pure function, we are indicating that we want the missing data method to be automatic, to rid us of any missing data. In applying the smooth histogram, we see this plot, which is rather hard to interpret. You know what we can do though? Let's set up a manipulate in which we can select which city we want to highlight to be able to look at the data more closely. We'll also set up a special plot for Chicago. We'll start by doing that. This code might look intimidating, but we'll deconstruct it from the inside out. We'll first take the key corresponding to Chicago in our cleaned wind speed data. Then we will use the key value map function to map our tooltip function onto the keys and values of our Chicago data. Our keys would be the Chicago entity itself, which will be #1, which is why we put it as the second argument in our tooltip. Our first argument are the values or actual data, which correspond to #2. Now let's move on to the manipulate. Using the show function, we will first show our special Chicago plot. Then we will plot all distributions that we did not select with a low opacity. We'll do that with the key drop function, which will basically remove the key that we will select. The rest of the code here is similar to what we did in the Chicago plot. Finally, we will plot the selected distribution as black to highlight it using key take. And then we'll set our initial city as Fort Worth and our options for the slider as all the keys in our data with Chicago deleted using delete cases. Alright, this was a marathon, but now we have a nice and clean visualization. The red dashed line is Chicago, the black line is the selected city, and the rest of the lines are the non-selected cities. Hovering over the lines that seem to be our red dashed line, which is Chicago, it looks like New York City and San Francisco beat Chicago again. Let's plot these top 3 contenders to find out who we will give the crown to. We will use key take to get the top 3 contenders, and it looks like San Francisco takes the crown. Its mean wind speed is the highest, it has much higher top wind speeds, and its distribution generally seems very windy. Maybe people will catch on to this soon and name San Francisco as the Windy City.